In week 4, we will be examining temperature, heat, expansion, heat transfer, change of phase, and thermodynamics. Temperature. Temperature is defined as the quantity that tells us how hot or cold something is compared to a standard. The higher a temperature of a substance, the faster the motion of its molecules. Specifically, within each of the atoms and molecules, the electrons get excited and move more rapidly. As the electrons collide against one another, if enough collisions are present, referring back to the material from week 3, we can have what is called a change of state or matter. We commonly use thermometers to measure temperature, and temperature can be given in 3 forms or measurements. Of course, we're all familiar with degrees Fahrenheit. However, the standard measurement is degrees Celsius. And scientifically, we use yet another measurement or scale called the Kelvin scale. Heat. The energy that transfers from one object to another because of a temperature difference between them. Technically, there's no such thing as absolute cold. We're referring to a lower state of heat and a lower state of energy. The direction of spontaneous energy transfer is always from the warmer to the cooler substance. When we are measuring heat, we refer to the calorie. A calorie is the most common measurement and is defined as the amount of energy required to raise 1 milliliter of water by 1 degree. Specific heat is the capacity of a substance to store heat, and it depends on its chemical composition. Objects in thermal contact at different temperatures tend to reach a common temperature in 3 separate ways. In heat transfer, we refer to number 1, conduction. This is the transfer of internal energy by electron and molecular collisions within a substance, especially a solid. As mentioned before, electrons get excited with more heat energy present, and they have more of a tendency to bounce into one another. The second way heat transfer may occur is through convection. This transfer of heat involves only bulk motion of fluids. The third way we can transfer heat is through radiation, and this is the transfer of energy from the sun, solar energy, through an empty space. The diagram down below gives us an example or examples of conduction, convection, and radiation. As an extension of week 3, we are now discussing phases of matter in week 4. We now know that there are 4 common phases that are the cause of the transfer of internal energy. The phase where there is the lowest amount of energy between the subatomic particles is known as the solid phase. If we're using the example of water, this would be ice. In the liquid phase, ice actually melts to water. Again, through heat energy, we warm the ice, and the atoms within the H2O molecules start to bounce against one another and actually collide much more. Due to these collisions, it expands the intramolecular bonds of H2O and results in the liquid phase. If we continue to add heat energy to the liquid phase, the subatomic particles, essentially the electrons, will continue to get excited and move even quicker than before. And by bouncing into one another and against one another, they form what is known as the gaseous phase. This phase occupies the most volume out of the 3 phases we have discussed thus far. In the plasma phase, vapor actually disintegrates to ions and electrons. And just so that we understand, an ion is an atom, but it has a positive or negative charge, which means that it has either lost or gained electrons. When discussing these phases of matter, the changes between each of the phases are actually given terms or definitions. We all know that if ice turns into water, it has melted. If water is frozen into ice, it is solidified by the process of freezing. However, When a liquid changes to a gas, it is important to understand that this concept is known as evaporation. The opposite also occurs. If a gas is compressed or the energy levels are lowered between the molecules, this will result in a liquid. There are laws of thermodynamics that we need to understand as they explain the states of matter, the phases, and the changes between them. The first law of thermodynamics states that the heat added to a system transforms to an equal amount of some other form of energy. Back in week 2, we learned that energy is not created or destroyed, it is only transferred. And this concept is proof of Einstein's rule. In the second law of thermodynamics, heat itself never spontaneously flows from a cold object to a hot substance. It just doesn't work that way in nature. Heat will always flow from a hot substance to a cold object or substance. In the previous slides, we've referred to the collision of electrons due to an excited state of energy, and we haven't yet put a term on it. However, entropy is a way or a measurement of looking at the amount of disorder or randomness in a system. If disorder increases, entropy increases. Thank you for listening to the introduction for week 4. We wish you success in your submissions and your learning objectives for this week.